Welcome to Science Spectrum with Don. This is the second part of the third lectures in dimensional analysis. The first part, we discussed extensively on the interconversion of units, which could be between the English units and the SI units, and of course, and vice versa. So in this aspect, in dimensional analysis, in this aspect, we would focus more analysis. We would focus more on the verification of equation. So this is physical equations verification. This is the aspect we will trace on this. All right. Now, having said this, I could make a reasonable guess about at least two physical quantities which must not exceed 3, else it becomes a challenge. All right, so this is the plausible assumption I would like to make. The first thing first I want to make is I could say the mass of the largest stone in water, okay, depends on the velocity of the water. That means for it to flow, for the largest mass to flow in water, it depends on the speed of the water itself. Okay, let's say raised to a power A. It depends on the density of the water raised to power B, and of course, gravity should act on it, so power C. All right, this is just an assumption, and of course, I could verify this statement if each of these quantities actually, okay, come into the equation of that. Let's see if any would be missing or not. All right, so let's get started. The dimension for mass is capital letter M. But this is raised to power 1. I could replace this proportion sign with an equal to with a constant of proportionality. This is velocity. Of course, that is, the dimension is LT raised to power minus 1. And of course, this is, okay, I could stick in the symbol, dimension. Of course, this is raised to power A. Then this is density. Density is mass per unit volume. This is M. Then volume is R raised to power minus 3. This is cubic meter. So this is M, L raised to power minus 3. This is raised to power B. Then this is gravitational acceleration. That's LT raised to power minus 2. This is raised to power C. Now, if we compare, if you look at this, both sides of this equation, you would see the mass is on the left-hand side and also on the right-hand side. But there are terms that are missing on the left-hand side, which are the length and which is time. So what it simply tells you is that on the left-hand side, the length is raised to power 0. That's why it's 1. 1 times this time gives you this back. And of course, time also, which is not here, means it's raised to power 0. So both of them represents 1. So that is the more reason why we are left with m raised to power 1. And of course, this is K. Now, this is L raised to power A. This is T raised to power minus A. Then this is M raised to power B. This is L raised to power minus 3B. This is L raised to power C. And this is T raised to power minus 2C. Alright, the next phase of this would be just to compare the powers of L, T, and M on both sides. Alright, but I may need to do some massaging on the right hand side because you could see L and L here, and of course T appears twice, so I may use the law of indices to group that. So I have on the left side L raised to power 0, T raised to power 0, which is 1, and I have M raised to power 1. Then this is K. Now L raised to power A, this is the law of indices now, the same base, and I'll add up the power since they multiply. So the first power of L is A, then the next power of L is, then I'll stick in the plus because of the times in between, then there is a minus 3b plus, then the next power of L is C. Then I'll go to T, I have, T would be, okay, T is, I have minus A, the first power, plus, the next power is minus 2c. Then for m, just m raised to power b, m raised to power b. So I could repeat this as l raised to power 0, t raised to power 0, m raised to power minus 1, k, l, plus and minus gives us a minus, so this becomes a minus 3b plus c, plus times minus gives us a minus, so I'm left with t raised to power minus a minus 2c times m raised to power b. So all I'll do is I'll compare the powers of this dimension L, okay, t and m on both sides. Alright, so let me start off with L. On the left hand side, the power of L is 0. This is dimension for L, so to speak. So this is 0. And of course on the right side, this is a minus 3b plus c. We'll call this equation 1. Then if I compare the power of t, for the dimension t, this is 0, and this is on the right side, this is minus a minus 2c. We'll call this equation 2. Then for on the left hand side, this is 1, and of course on the right hand side, this is a b. So this is equation 3. So this immediately tells you and I something that b is 1. B is 1. Please, we need to bring this a little for the sake of notes. Alright, so we proceed. Now, b already tells us that is 1. So b is 1. B is 1. Now, if b is 1, it simply means that, okay, from equation 2 now, I do know that if I flip this, if I transpose this, I'll get a is equals to minus 2c. So in other words, anywhere I could see a, I could stick in minus 2c. And of course, I could do that in equation 1 since b is 1. And of course, I could replace minus 2c for a. And of course, we're good to go. So let's go ahead. So 0 is equals to a is minus 2c minus 3. B is 1. 3 times 1 is 3.5 plus the c. So this becomes minus 2 plus 1. That becomes minus c minus 3. And of course, this is equals to 0. So sticking minus c here and transpose, we get a 3 here. So if you divide through by minus 1, this immediately tells us that c becomes a minus 3. Now, since I know c, I know b, I could find a. So all I'll do is I'll plug in minus 3 for c, and I'm good to go for a. So a is equal to minus 2c, and of course, a becomes minus 2, c becomes a minus 3. Minus 1 gives me a plus, so a is simply plus 6. Now, having done this, I'll go back to that assumption I made earlier, and of course, I will just replace the powers, and we are good to go. Alright, now, if you recall, the assumption I made was based on the fact that the mass of the largest stone in water depends on the velocity of flow of the water. It depends on the density of the water, and of course on g. That's g raised to power c. That's acceleration due to gravity. All right. So we did replace this with equals to with a constant m, and of course this is v now. A is immediately 6. Then the density B tells us is 1. I did not indicate the 1. And of course, GC immediately tells us that is minus 3. So I could replace that the mass of the largest stone in water, that's okay. For it to float, the condition is I have kV raised to power 6 density. Then this is 1 over g raised to power 3. I could just divide both sides. Just divide through by g raised to power 3. And of course, all of these quantities come into the equation. So it means that assumption I made is actually valid. Now the next example is the famous gas law. PV is equals to nRT, but it's written somewhat like this: P plus open bracket P plus A over V squared times, this is pressure, then V minus V, this is volume, then is equals to RT. This is the general gas equation. All right, the question is this: find the constants A and B. That's the question. Of course, we could easily hop into this and get the answer as quickly as possible. All right, this term is pressure, This term is pressure and this term is volume. PV equals NRT as you like it. N there means the number of moles. Alright, so P plus A over V squared. This is pressure. This is pressure. So I do know that A over V squared is the same as pressure, definitely. So pressure has dimension. V, we know is volume. So this is, volume is on L raised to power 3. But of course, this is carrying, everything is carrying power 2. So this becomes L raised to power 6. Then pressure is force per unit area. Force is in Newton, which is kilogram meter per second squared. And area is square meter. So I lose this. So I have kilogram per meter per second squared. So pressure will have the dimension of M, L raised to power minus 1, T raised to power minus, this is over 1. And of course I'm looking for A, so if I cross multiply, A becomes now, sticking, so A would become M, L raised to power minus 1, T raised to power minus 2 times L raised to power 6. And of course the law of indices, A becomes M, minus 1 plus 6 gives us a 5, L raised to power 5. And of course I'm left with T raised to power minus 6. This is what A represents, that is its dimension. And of course, to find the B, which is volume, V minus B is volume, that's volume. And of course, I could transpose this, so I have minus B is equals to V. And once I flip this, this becomes a minus V. But of course, I need to eradicate the minus sign here, so I could multiply through by negative 1. And once I know that I have minus B, this will be equals to minus V plus a V. Alright, so of course, okay, by negative 1, this is, alright, this is it. So, but of course, this is just a 0, but I'm particular about what volume is all about. So, B is simply volume, so to speak. Alright, so B is volume. And what is volume is simply L raised to power 3. And these are the dimensions of the constants A and B in the general Gauss equation. Thank you for tuning in. If you're new to this channel, you want to like, share, and subscribe for more content. Thank you.